Nice.
Okay, let's get started. Welcome everyone to Baseline Tech Talk Tuesday. This is season 2, episode 34. 34. And if you're joining us for the first, I got this, Dan. I did my homework. I prepped. If you're joining us for the first, you can catch all the replays on YouTube. And the current handle, which may change in the future, is Baseline Web Training. Baseline Web Training. All one word on YouTube. You can find all the previous Tech Talks as well as Dan's helpful how-to videos and worlds of other helpful information.
Absolutely.
So let's do quick introductions. We've got Chris, London is calling right, VP of Sales. We've got Dan, the water geek Conger. And we've got myself, Andy, always ask why, Humphrey. Changing it up today.
Nice. Excellent.
And what we're going to be discussing today, the product is the FlowStation, but we're really going to be talking about what you do with it, the solutions you solve with it, why it's important, and to give you that sort of fundamental knowledge base so that you can think of it not as just a box that hangs in the field or hangs somewhere, but what you actually do with the product. And so
what its purpose is. And as we think
on
about it, I really think that the FlowStation is probably one of the most misunderstood and underutilized performance components of a baseline system.
Yeah.
So,
and it has as much technology as the controller. It's just sort of seen sometimes as this ancillary product that really does, one thing, but it doesn't do just one thing. So that's what we're going to talk about. It does so much. So Dan, why don't you kick us off, and then Chris and I will chime in and try to distract you.
Okay, perfect. That, as always, right? Well, something that just kind of clicked in my head was what I'm kind of curious what each of us think the FlowStation does, and I guess what I was thinking in my head was the base station 3200 can just handle hella flow, right? It can do lots of flow management. But what happens when the base station 3200 when you have more complex flow than that controller can handle? We just bring more on. For me, that's the definition of the FlowStation. The base station 3200, we've reached that. You're pushing the limits of it. What's my resources? It's FlowStation.
Right. So define a couple of those limit pushing functions.
Oh, sure. Yeah. So one of them is we can handle 8 water sources, 8 control points, and 8 main lines in a single base station 3200. Exceed any one of those, you're going to need a FlowStation to manage it as a whole. That's probably the biggest single one.
All right. So does that mean you need a FlowStation in order to handle 10 control points on a base station 3200?
If you want them all on the single base station, that's like a
trick question.
That was a good quiz. It's not a trick question. Yes, you would if you want to manage it all together as one cohesive unit.
Can a 3200 handle 10 points of connection or control points, Dan?
8. I just said 8.
I know, but my question was, see, we tripped him up already, Andy.
That's why I said it was a trick question. You got to think outside the controller.
Yes, right. So a FlowStation comes into play if you exceed the flow capacity of a 3200, requiring another 3200 to be put on the same hydraulic structure.
Yes. You tricked me in the first 3 minutes.
Now, what's interesting, that's kind of like a softball pitch to the first thing that people think of the FlowStation is its job is singularly to manage multiple controllers. A lot of people put it in that box. It's a multiple controller manager. And that is one use case, but that's not the only use case.
Right. But if we've got multiple controllers that are all managing their own water source or control points, is a FlowStation needed?
There are scenarios where you would, absolutely. Right. So you might have 5 controllers and each one has just one water source and one control point. There are cases where you might want a FlowStation or need a FlowStation to manage that.
Okay, neither one of you have said the magic yet, because when I think of how market perceives the FlowStation, it's when you've got 3200s that are sharing water sources.
Yep. Sharing flow.
Right. So that is one use case of the FlowStation in working as a performance component of 3200. However, there are more functional capabilities of the FlowStation when working with just a single 3200 as well, which is what we want to highlight and talk about today.
Yeah. Yeah. And I've got three use cases. So let me just show you my first one. And that's that simplest case. And that's going to be a single water supply, but multiple controllers. So, so on this site, this is it's a county complex that, like there's a courthouse and the police and all this fire on this one. There's 5 controllers installed around this site. It could be 5, it could be 8, it could be any number of controllers on there, but I'm using 5. This site has 1 master valve and 1 flow sensor, and they happen to be connected to controller A, not controller B, C, or D. And then there's 1 shared main line in the site. So we're sharing flow and we're sharing flow resources, exactly what we were kind of starting off with. So what are some challenges, right? Let's talk about the challenges that come across a situation like this without the FlowStation.
Well, a lot of it depends on how big your design flow is for that main line and the scheduling so that you don't exceed the flow capacity of that main line by operating multiple controllers at the same time.
Yeah, well, not only not exceeding it, and also optimizing it, managing it correctly.
Yeah. So if I had a 10-inch main line and a bunch of 10 GPM drip valves, I wouldn't care. That very likely you wouldn't care too much about it. But if I had a 2-inch main line and a bunch of large zones, that's going to be a real bear to try and manage it. And then we need to juggle all of the flow amongst all of those 5 controllers, and FlowStation is going to be ultimately the way to do that.
Yeah. And we
5
talked
controllers,
about it
though, Dan,
before.
that would work well for 5 days of the week. Controller A just runs Monday. Controller B runs Tuesday. Controller C runs Wednesday, right? Isn't that the way we've always done it?
Yeah.
Tuesday at 10 o'clock is not a good reason to water, Andy.
Yeah.
No, it's not. Right. Because we've said it before, our limiting factors on any site are really going to be the size of our water source and our design flow and our available water window.
Yeah.
Right.
Right. Okay. So let's talk about how we're going to address that. So actually, let's rehash some of the goals that I think there are. And there may be some other goals for the manager, but to share that master valve and to share that flow sensor with all 5 controllers, right? So we want to share that information, share the water resource. Now we could change out the master valve for a pump station, or, we could change that out, but we don't want to do this calculated opening time for the master valve. So in this, from being a contractor, I've done this before. And it's like, well, I'll leave the master valve open during this time when all the controllers are going to run. Or to Andy's point, maybe I run this controller on Monday and this on Tuesday. That's a bunch of baloney, right? And if it's a normally open, normally closed master valve, you're just trading problems, right? When do I open the master valve? When do I close the master valve? There's really no gain on there. The other one I tried doing a long time ago is I had 2 controllers, 1 master valve, and I tried a relay to switch it back and forth. That wasn't pretty, but try doing it with 5. I don't know what that looks like. That'd be ugly. And then we want the correct flow data for each controller. So that's what I'm working for on this site right now.
Mm-hmm.
So here's how we'd pull it together is we'd install the base station 3200, so that we got to have all 5 controllers have to be base station 3200s. Do they, Chris? Let's see if I can try. Do they have to all be base station 3200s?
Not necessarily.
Oh, okay. Well,
okay. Depends on what the overall capacity of the site is. If
right.
it's
We could have
200
substations
zones
and such, but then we
we
wouldn't
can
need to
use-
share the flow. I mean, really,
Right.
if this entire site were less than 200 zones, we just, might just need 1 controller.
Yeah.
True.
Yeah. Excellent. There we go. I tried to throw them a curveball. It's not going to happen.
I was going to add this at the beginning because in this scenario, oftentimes singular controllers are requested because they want to give the user their own control, right, at the device versus a substation. It's only the controller on maybe the one building.
Yeah. Okay, so then we're going to want the FlowStation somewhere installed on site, but then we need a communication method. We need some way for the base station 3200s and the FlowStation to communicate and to share information, because really this is going to be moving data back and forth, and we want to do this in real time. So multiple communication methods, right? So it could be Ethernet, it could be a Wi-Fi cell, Ethernet radio. Any of those methods will work to share this data amongst our network of devices. Mm-hmm. And then we're going to do it in App Manager. And it's certainly the easiest way to do it online is to connect these controllers and allow them permission to talk and kind of know who's going to get their marching orders, or how the FlowStation is going to play with these controllers in there. And then this is kind of a thing that's good to remember. It's real basic for us, is the programming is done in the base station 3200. The FlowStation is just going to ultimately manage or control that flow, but not all the zone run times and the start times. That all resides in each individual controller. So that doesn't change at all.
So how does the FlowStation know what the programs are for the 3200?
It doesn't.
Is there an assignment that we have to make in the programming in order for the FlowStation to manage that?
We do have to assign the water source in the 3200 to the FlowStation. So that's where that water and perhaps the control point. That's the component that the FlowStation is going to manage, not the run times, not the programs. So I think I've got. Oh, there we go. We got to assign that master valve and flow sensor and the controller in App Manager. We've got to create that association or assignment.
Okay, so just to clarify, the FlowStation is not managing the programs as they operate on the 3200. All the FlowStation is doing is managing the flow available based on design parameters for the 3200s to operate their programs.
Absolutely, 100% correct, right? And that's a great clarification.
Yeah, and Andy, it brings up, what we were talking about earlier, is that, the 3200 itself is very powerful in its capability, both programming and support, but it requires another algorithm in order to be able to manage the design flow for multiple controllers that may be on a hydraulic structure. And that's where the FlowStation is needed, because it has a different operating algorithm coded in it that helps to manage that.
Yep. Different algorithm. It's powerful, requires more horsepower than one single controller is capable of doing.
Yep. All right. So just out of curiosity, and for clarification, how many base station 3200s can be operated by a single FlowStation?
Is it? Oh, okay. I'm gonna make this as a question and rather than a statement. Is it 20?
Question with a question. I love it.
Is it 20?
It is 20. Yes.
It's a statement. It is 20.
It is 20, right? So 20 3200s could be operated by a FlowStation. How many different main lines can be managed by a FlowStation?
Are you going to make me do math? Is that what this is going on? Okay.
Aren't you the training manager?
Yeah, but I'm not a math whiz. Well, let's see. If each controller can handle 8 main lines and I can handle 20 controllers, what's 20 times 8?
No,
I got that wrong. Okay.
You got that wrong. So
okay.
We can.
That's right. I did get that wrong.
We can have 40 main lines.
Okay.
20 controllers, 40 different main lines.
Which is still a lot, Dan. I mean, it's not 160, but it's a lot.
So ultimately, it makes it possible for us to manage the operation of 4,000 zones at scale.
Okay, that's a big number.
Yeah. Not common on a lot of sites, but there's a lot of sites that come close to that.
Yeah. So I think that my next scenario is kind of start looking at more of those main lines and that breakdown. So to finishing up on this one is really, right, so the FlowStation needs to be installed somewhere on the site. Practical purposes, you're probably going to put it adjacent to another controller and just kind of cut down your communication. But then we need that communication, right? So, and this illustrates really easily. It's in the center, wherever it is, doesn't matter. But what's happening here is controller A is physically wired to the flow sensor and master valve. When controller C wants water from the master valve, when it wants the master valve to open, it's not going to talk to controller A. It's going to talk to the flow station, and then the flow station will tell controller A to open the master valve. Or likewise, if controller D wants to know, do I have 100 GPM? Because I've got 100 GPM worth of zones I want to run. It doesn't query the other controllers. It gets the information from the flow station. The flow station is that overarching management of flow, but only flow, not programs.
Okay. So to take your explanation a little further, if controller D asks for 100 gallons of water and there is capacity available, but not 100 gallons, what happens?
It'll say, I've got 75 GPM. What are you going to do with it? And then it will, if it only has 100 GPM zone, then it doesn't have anything that's going to run. But if it's got, 75 GPMs worth of zones to take advantage of that 75 it's allocating, just like it's exactly what it does within the controller, right? Managed by flow isn't in the controller, but this is now managed by flow for our system.
Right.
Correct.
Same concept, just one level up or 2 levels up.
Right.
Yeah. Yep.
Yeah. So I think if you understand the concept of managed by flow within the 3200, this is the same thing.
Mm-hmm.
Yeah.
All right.
And then the same thing, it could also do electrical capacity, right? So it can manage, manage it on flow or manage it on transformer, the ability of the transformer. We've got multiple transformers, so it can definitely get into some very complex flow. Here we've got a single water supply, single water source, a shared main line, multiple controllers. Probably one of the more common needs for this, or when people first think it comes up, but my next case study is definitely more sophisticated this.
Okay, let's see that.
Cool. So on this site, we're going to talk about submain lines. So this site is a large planned community. We're going to look at 3 controllers, but to Chris's point earlier, it could be 3 controllers. Maybe we'll want a flow station for just 1 controller. Let's ask that question again later on. Mm-hmm. I've got 1 water source. So that's a pump station, 1 master valve, and 1 flow sensor. So, and a single shared main line, but that main line branches and changes size throughout the system. So we've got different size main lines in here. So let's kind of talk about the goals and the things that we want to do on this one. We want to set different capacities for each one of the main lines. So one section of the main line is 10-inch, another section is 4-inch, and another section is 6-inch, right? Different sizes. And we don't want to set the 4-inch capacity for the 10-inch. We don't want to starve that. We want to pump a lot of water through the 10, but don't try and shove that, I don't know, I'm going to make up a number, 1800 GPM through a 4-inch pipe, because that's going to be problematic. So we want the appropriate flow for each main line. And then if needed, we want to isolate submains, and then we could even get better flow resolution on those submains as well. So we could see that flow better on the 4-inch as opposed to the 10-inch. So those are 3 things that we want to kind of look at, but there's other benefits that we could come up on this one.
Mm-hmm. Control. We get control of that main line.
Yeah,
really.
Yeah, exactly.
Yeah. If we look at the new flow setup in a 3200, we changed it. I believe it was starting at 16.0 firmware, where we went from assigning zones to programs and programs to POCs. We changed it so that we're assigning zones to main lines to control points to water sources, right? And so that allows us to then execute on this water management strategy in managing how the hydraulics flow through the system to provide water to zones that need it, right, based on their programs.
If you think historically, where did a master valve and a flow sensor go on the system? At the start, at the beginning, right?
At the point of connection.
We've taken that concept and allowed it to go down the piping system, downstream, to give you better control of the hydraulic system. Hence, control point does not mean POC, right?
Nope.
It's a point you want control of your piping system.
Exactly.
So to that point, let's take another look at this picture. If you notice, there are 4 sets of control points on the system. So calling it a master valve is kind of a weird name, because the master valve, to Andy's point, implies that it's the beginning of the system. But I've got one way up at the top at all these different spaces. We've got 4 different master valves. So they have to be coordinated and they have to work right. But when that happens, there's some real advantage to this
right.
one.
Now, remember, we're talking about the functionality of the FlowStation. That's the key here, not the 3200 controller. Yes, it's there, but it's really the functionality of the FlowStation that allows this to happen. So if you had a singular controller and you wanted this, you need a FlowStation.
Right. Because the only way we're going to get those multiple control points to work is when we have a FlowStation and we allow it to communicate and to share that data with. Well,
even a single controller, only the FlowStation has the algorithm to do the Submain Line, capability that we're talking about.
Correct. Yeah. So Dan, do you have your control points numbered?
I don't. I missed that one.
Okay. So which controller is the pump station connected to?
The one down at the very bottom. Bottom center. Yep.
All right. So let's assume that we've got a system that's within the operating capacity of a 3200. So eight control points, 200 zones, right? And we didn't have the other 2 3200s. So how does the FlowStation know which control points to open when, based on the single 3200 scenario?
In a single 3200 or with multiples, we're going to be using the control point grouping function, and that's set up in App Manager via FlowStation, right? That's going to, so basically the additional layer of hydraulic setup is going to come with FlowStation, and that's that algorithm, the additional data and the data processing. Even though we may not technically, you might say, well, you don't necessarily need it to manage more controllers, but we do need it to manage these advanced hydraulics, because this is definitely advanced. So
the takeaway and the thing to remember is the functionality, as we call it in baseline language, is control point grouping. And what that means is if we've got a single 3200 on this hydraulic structure and control point 2, which is a leg off of the mainline, calls for water, the 3200 needs to know to turn on the pump station and also to open that control point. So it's opening 2 different control points, right? In order to provide water for that leg. That's how that functionality works. And it's called control point grouping.
Yep. And it's not a grouping that's side by side. That's why the words are sometimes confusing, because those devices could be a mile apart from each other.
Correct.
They have to open at the same time. They might be a mile apart from each other.
Yep.
And we all know that most sites actually are single controller, right? Most sites in the world, and many sites that are 150 zones might start with a 4-inch and have some 3-inch and have some 2-inch and have some manual isolation gate valves out there. And you can replace those mechanical manual valves with a control point and automate it.
Correct.
Right.
So, and one of the advantages of it is that it provides you better flow resolution, because the main lines associated with those control points may be of different size, but it also gives you that isolation capability, right? So you can isolate that 6-inch main if you've got a problem on it by just disabling the control point until you make the repairs and fix it, and then can operate as normally, right?
And today we got to send Joe out there to close the gate valve.
Line. Yep, exactly.
Yeah. So to that point, though, with the control point grouping, when I have zones that want to run on the yellow 6-inch main, I'm going to open the 10-inch control point at the beginning of the pump station, and the 6-inch control point, open those in unison to allow water to those. Or maybe it's the 4-inch, right? Where you open the 10 and the 4-inch to that control point grouping. The other thing that's important about this, right, is if there are zones directly attached to that 10-inch main line, we know that we can run a lot more zones together in combination because the 10-inch has a very high design capacity. But when we get over to that 4-inch purple main, there's much fewer zones that we can run concurrently at the same time. So we have different, we have the ability to isolate each section of submain, but we also have the ability to set different design capacities for each one of these main lines and open only a certain number of valves depending upon the capacity of that submain.
Yep. Exactly.
Now,
right. That's a good illustration.
What about these 3-inch mains? Those there's no control points on those blue 3-inch main lines. So how does that work with this one?
Okay.
Those aren't submains.
No,
Right,
but they're mainline to mainline configurations, right? So you've got different flow capacities associated with the different pipe sizes, but you don't have a control point. So it's a main to main.
Yep.
Also comes from the FlowStation, not within the 3200. And so we could say on the 3-inch main, you could open this many valves. We know that it knows the design capacity. On the 6-inch, it's a different capacity. The only thing here is on a main to main is we can't isolate that 3-inch main because the only way to isolate that 3-inch main is to close the big 10-inch back at the beginning of the pump station.
Right. Yep. But it can help us to manage the concurrent operation of zones that may be on both of those 3-inch mains to take advantage of the available water that's present from the
and not exceed the size of the 3-inch, so you can still have your concurrency restricted by flow.
So it's balancing hydraulics so that you get optimized performance with balanced pressure across that.
Right, because on complex sites like this, I could see your watering time, just your water time and water window just being really difficult to manage. And a FlowStation is probably the best way to manage that across probably the only way to manage that across multiple controllers or just a complex single controller.
Yep. So that's why the FlowStation is able to manage 20 controllers, 20 3200 sharing water sources, but also 40 main lines because of this type of a mainline to mainline configuration where you may not have a control point associated with it. It's just a T in the pipe where you go from one pipe size to a smaller pipe size with a different flow characteristic associated with it.
Nice. Excellent.
Okay. Awesome. All right. You got more illustration? Or?
I do. You're going to have to cut me off when we run out of time. So,
all right.
Okay. So let's take a look at one where on the same site, that 10-inch master valve is sized for that maximum flow, and the 10-inch flow sensor is sized for that maximum flow, but we have different flow rates throughout the system. So we want, if we want to see and react to different main lines, and then maybe change the master valve closing speed, because the 10-inch master valve, I don't even know how that closes. That's well beyond the scope of what I'm familiar with. But what we could do is we could do that same FlowStation and 3200, but now I can start getting into a bypass configuration. So I'm going to use a 10-inch flow device and an 1.5-inch flow device, create the programs and the controllers like before, and we're going to use control point grouping again. So this is another application of control point grouping. So here's an illustration where we've got the 10-inch control point, but I could install an 1.5-inch control point as a bypass. And some of us have seen bypasses before, and they have different ways of managing it. This is an active way. We're going to actively manage this control point. So so we've got to have the FlowStation for this one. And this is going to use the smallest water source first, and then it'll switch to the larger one as it demands, and then it'll switch back and forth if needed, right? So if the demand, as soon as it exceeds that 1.5 inches, it will overwhelm it and then switch over to the 10-inch. Ooh, this is a good reminder. Real time. This is based on real-time flows. This isn't calculated. This is what's happening real-time in the system. So here we've got those two control points. If we've got a low demand on one side, just a couple of drip zones are going to open. Well, we're going to get a quicker closing master valve, and the flow sensor will be easier to read that 30 gallons a minute than that 10-inch. So in that case, it will open up the 1.5-inch control point because it can handle the flow.
Mm-hmm.
Now we turn on the big guns and we're calling for 200 GPM. Immediately overwhelms that 1.5-inch control point, and wrong way. And then what happens is that overwhelms it, and it will open the 10-inch, right? So it can, and then as the demand drops off, it will switch back to the 1.5 inch.
Mm-hmm.
So we can play that back and forth with control point grouping. Got to have the FlowStation involved in this one though to get this sophisticated.
Absolutely. Yep.
Well, this is good. I mean, I'm sure everyone learned a little bit today. And just as a reminder, the best way to learn is to go try it, do it, get on the site, program it, get your hands dirty, as they say in the irrigation industry.
Yeah. Well,
awesome. All right. We're at the bottom of the hour.
Wow.
So another 30 minutes blown by. Appreciate everybody joining us today for Tech Talk Tuesday. I think it's great information. I think that warrants another one in the future on the same topic because it does get a bit complex in understanding how it works and how to optimize it.
And sometimes it's hard to break out of what we may have been taught in the past and what's available today, because we keep wanting to go back to what's comfortable, what we know, how do things work, and it's hard to see the new way.
Yep.
Yeah.
So we're here to help answer questions and help you deliver an engineered solution to your site or your client. So if you've got additional questions, please let us know. You can also obviously reach out to your regional manager from whatever part of the country you are in to get more information. But we thank you for joining us today. Go out, work hard. Have a great rest of the week, and we will see you next Tuesday, same time, same place.
see you all next week.
All right.
Cheers.